If I say to you tomorrow, take my hand, child, come with me to a castle, I will take you. But what's to be, they say. Catch the wind, see a fin, sail away, leave the day way up high in the sky. Let the wind blow, really set it go, Holy Ghost to shout. That you will be mine, I'm taking our time. So if you say... Alright, hi there. Today, I'm going to be looking at, for Algebra 2, Chapter 5-5, Theorems about roots and equations. The first thing we should talk about is how, when I say roots, that means really it's where the graph, the curve, crosses the x-axis, which means we also call it a couple other things. Roots is the same thing as x-intercepts, is the same thing as zeros. So if I ask for one of those things, you'll see the questions phrased in any one of those three ways, and they're all asking for the same thing, okay? So x-intercepts is the same as roots, is the same as zeros. Now, when I'm doing this is the main idea here with the finding the roots. If they give you a big equation, what you're going to do is factor the constant term, which is the regular number, and that'll be the numerator, and the factor of the leading coefficient will be the denominator. So that's why that's a fraction bar in the middle there, right here. All right, so the easiest way for me to do this is really to show you an example. So here's what I mean. So if I gave you this and said, what are the rational roots? Rational, remember, that would be like, anything that can be written as a fraction. Rational numbers versus irrational numbers. All right, so square root of 2 is not a rational number, but 1/3 is. All right, so the leading coefficient is 2, all right, and the constant term is 5. So that means the factors of 5 are going to make up my numerator, and the factors of 2 are going to make up my denominator. And then it's any combination of those two things. So you can see, and it's the plus or the minus have to be taken into consideration also. So if I take 5 first, and excuse me. So the factors of 5, if I go, I'm going to put plus or minus because all of these are going to turn out to be positive or negative. So I got 2 of them, right? Over here I've got the denominator. So it could be over 2 or it could be over 1. 5 over 1 is 5, you could write it as that, okay? So there's 4 roots, right? Because they're both plus or minus, which means it could be 5/2, -5/2. And then I've got the 1 over here, so that's going to be, I'm going to have 2 of those also. These are also plus or minus. And then I'm going to put it over 2, and I'm going to put them over 1. And that should be all of them. So if you wanted to like list every single one of them out, you could go, 5/2, -5/2, 5, -5, 1/2, -1/2, 1, -1. You might find some repeats in there occasionally. You can cross those off. Anyway, like I'm fine with this up here, writing it like that. If you want to write it on the bottom and list every single one, that's fine. Okay. All right, so you can see that, that was only with 2 prime numbers, with 2 and 5, and I still came up with, 8 roots. So there can be a lot of numbers, especially if you have something with a lot of factors, If I put, 12 on there as the numerator, well, then as the leading coefficient, you're going to get a lot of them. And you're going to see it can be time consuming to figure out which ones are actually the roots. These are possible roots. These aren't actually necessarily all of them true roots. but possibilities. So now that I've said that, let's go to number 2. What are the rational roots of? Write this down. What are the rational roots of 15 x to the third minus 32x squared plus 3x plus 2 equals 0? Okay, so possible roots. I got 15 and I got 2, right? And so this could be 2 over 15, 2 and 1. This one's 5 and 3, or 15 and 1. It could also be 2 over 1. You can see there's going to be a lot of these. These are all plus or minus. It could also be 1 over 1, 1 over 15, 1 over 5, 1 over 3. These are all plus or minus. So anyway, there's a lot here. And when you're going to start doing synthetic division is usually what you do to check and see whether it actually is a root or not. Now you could just start by, picking one of those numbers and start doing division, synthetic division on it. This is one of those things where it's not the way I'm going to do it. The easiest way to do this is with a graphing calculator. So if you have a graphing calculator, this is one of those times where you're in an advantage. If you don't have one, you're going to start doing synthetic division. Now, there's this wonderful program here that I'm going to use. It's called Desmos. It's like a graphing calculator. It's free. There's an app you can download on your phone also. It'll work there. You will not be able to use your phone on any of my quizzes or tests. So it's great to use it on your homework, but not so good for class. So you need to I'd recommend getting a graphing calculator for this, or borrow one or something. Anyway, so if I go punch that big 15x to the third, (15x to the third minus 32x squared plus 3x plus 2 into Desmos here. So what I'm looking for is where it crosses the x-axis. So it looks like, if this is 1, I don't know what that one is, between 0 and 1. But the one that's between 0 and -1, that looks like -0.2. And this one looks like 2. So I've got 2 possible roots that I can work with. I mean, you could try to figure out what that one between 0 and 1 is. It could very well be a third or something, but 2 and 5, 2 and 15, yeah, I'm not sure. Anyway, I'm going to use the other one. That one looks like -0.2 and 2. All right, so I'm going back over here. And I'm going to write down, looks like -0.2 and 2. All right. So now that doesn't mean that it is, but remember, if I go like this and I take that, this is x equals 2 and x equals -0.2, maybe. And then I go and take that and I'm dividing over here with synthetic division. Hopefully you remember synthetic division because it's going to play a big role here. So now I take these coefficients here of 15, -32, 3, and 2. Make sure that you've got all the numbers covered. I got the x to the third, x squared, x, and regular number. If not, you got to fill in zeros. If there was no 3x there, if it was just -32x squared plus 2, you got to fill in a 0 in between those numbers. All right, so back to this where I can now draw a line, bring down the 15, multiply, and then 2 times 15 is 30, and then you add straight down, and I get -2, and then you multiply again. 2 times -2 is -4, then you add straight down again, you get -1. 2 times -2 is -2. Ooh, that's nice, because I get a remainder of 0, which means it is a root. So x equals 2 is good, okay? So that's one of my rational roots. Now, you're not done yet. You want to find the other ones. You know, you got to find all of the rational roots here. When, write that down, when r equals 0, it's a root. And then what I usually do is I use this to find more roots. So I don't necessarily go back to the 15, the original 15, -32, 3, and 2. I'll use this one. I'll go 15, -2, -1, and figure out what the rest are, okay? Now, hopefully you remember, this is really 15x squared minus 2x minus 1, and it could be equal 0. But if I want to factor this now, I can just take this on the side and go, this is one of the harder ones actually. Sometimes it's nice and easier. This one's not bad at all though. With 15 times -1, that's a times c. And then you get -15, and I'm looking for the factors of -15 that add up to -2, which would be -5 times 3, and I split the middle. -5x plus 3x. Bring down the -1, the 15x squared. Draw a line down the middle. And I pull out a 5 and an x here. Leaves me with 3x minus 1. And over here, 3x minus 1. I can always pull out a 1, which means, in parentheses, I got my 5x plus 1. The other parentheses is 3x minus 1. And I'm not done. I need to solve this out. 5x minus 1 equals 0. 3x minus 1 equals 0. And if you quickly add 1 and divide by 5, I get x equals 1/5. Over here, add 1. Divide by 3, you get 1/3. So here's my 3 roots. No, I'm not going to forget that 2. That's a 3. One-third, 1/5, and 2. And those are my 3 rational roots, all right? I know that one took a little while to explain it. All right, so anyway, next one. Number 3. List all possible roots. Then find all rational roots. And the equation is x to the third plus x squared minus 17x plus 15. Okay, so this will be the numerator. The factors of that will be the numerator. And this will be the denominator. Remembering that there's a 1 in front of that x cubed implied, okay? So now I'm going to go, this will be factors of 15 are 15 and 1, 5 and 3. Over here is just 1. So I got 15 over 1 plus or minus 1 over 1, don't forget the 1, 5 over 1, and 3 over 1. So I got 8 of them again. And once again, I'm fine with that being written like that. I know that's 8 things as long as you do. You got to put the plus or minus there. All right, so now I got to find the possible roots here. So, you can start just dividing and see if they work or not. You can take 5, divide that out, my coefficients will be 1, 1, negative 17, and 15. And bring down the 1, that's a 5. Add down is 6. 6 times 5 is 30. Add down is 13. 13 times 5 is 65. You get a remainder of 80. So that's not a root, so that one wouldn't work. You can start out that way. I still kind of like going to that graphing calculator. Punch that equation in. I got x to the third plus x squared minus 17x plus 15. So, here we go again. Looks like 1 and 3. That's what looks like what I got. Oh, and maybe -5. 1, 3, -5. We'll see. Now, just because it looks like it is, doesn't mean it necessarily is. So it looks like 1, 3, -5. All right, so let's try 1. I like working with 1s. 1s are nice and easy. So it's x equals 1. If it was x, yeah, all right. And my coefficients are 1, 1, -17, 15. Draw a line, bring down the 1. 1 times 1 is 1. Add, multiply, add, multiply. 1 times 2 is 2. -15 is equal to -15. Oh, that's a good one. You get a remainder of 0. So x equals 1. That's a good one. Now, remember, don't go back to the original. Work with what's left here. Take this and use that as the next thing you're dividing into. 1, 2, -15. Space, I should move this. And I'm going to divide by the next thing. So we said 1 looked good. Well, this one's actually beautiful because, remember, if I started out up here with my first one was a x to the third, which means if I subtract 1 from the exponent, the highest one there will be x squared. This one will be x, and this will be a regular number. That is easy peasy to factor and solve because there's nothing in front of the x squared, which means I'm just looking at factors of -13 that add up to 2, which will be 5 and 3. And if I make the 3 negative, they add up to 2, so that's x plus 5, x minus 3. So x plus 5 equals 0, x minus 3 equals 0. You get your answers. X equals -5, x equals 3 when you add 3 to both sides and subtract 5 from both sides. Okay, so I got all my roots now. The first one was that x equals 1. I don't want to forget that one. There's my 3 roots. All right. Very good. So that was a good one. Next one. All right, going a little different direction this time. Number 4. What is a third degree polynomial y equals p of x with rational coefficients so that p of x equals 0 has roots -4 and 2i. So this one, they're going the opposite direction. They're giving you the roots and they want to know what the polynomial is. So what I like to do with these is I'm going to write down my 3 roots over here. That one, anytime that there's a positive 2i root, there's also a negative 2i root. Okay, not so with the -4, but with the 2i. If they had said one of them was -2i, you knew the other one was going to be positive. You can't have one without the other, okay? So now I got to put them in parentheses. So remember that, when I have -4 as the root, that's the same as x plus 4. Okay, and if I have 2i, that means it's x minus 2i. Over here will be x plus 2i. Okay, and that's what's in my parentheses. And if I multiply those things together and it equals 0, that's actually the polynomial. Now, because they said rational coefficients, it means I have to actually go through the process of multiplying those 3 things together is all. Okay, but that's probably the hard part right there. Really is just conceptualizing, what those roots really mean. Okay, so now I'm going to multiply these together. I'm going to multiply those two together first. Okay, I'm going to do it by FOIL. If I go first, x times x is x squared. Outside is 2i times x, which is 2xi. Inside is -2xi. And the lasts are minus 4i squared. Okay, now these two here cancel each other out, which means I got x squared minus 4i squared. Now hopefully you remember from earlier that I squared is -1. Okay, which means that's really -4 times -1, which is +4. So that's what I get when I multiply those together. And then I've got this extra x plus 4 over here that I need to multiply out also. And now if I multiply those together, x times x squared is x to the 3rd plus 4x plus 4x squared plus 16. And if you combine like terms here, I get x to the 3rd. Actually, I'm not combining like terms. I'm just switching the order. I always put my stuff in standard order. So I like the x squared in front before the x's, and my x's before the 16. And then I'll put equals 0 because it's going to be an equation. And there it is. That's the answer. All right. So do one more of these together, and then I'm giving you a U try, and we'll call it a day. All right, so I am on number 5. What are the x-intercepts of x to the 3rd plus 5x squared minus 8x minus 12. All right, so they didn't ask for the possible roots. So I'm going to go straight to my graphing calculator, punch that in there, and figure out where to start. Okay, x to the 3rd plus 5x squared minus 8x minus 12. Okay, so it looks like negative 6, negative 1, and 2. Negative 6, negative 1, and 2. Negative 6, 1, and 2. All right, so let's see if any of these here work. Okay, so let's try negative 1. I like doing ones and negative ones. All right, so this is 1, 5, negative 8, negative 12. Draw a line underneath, bring down the 1. Multiply and add, multiply and add. Negative 1 times 4 is negative 4. Negative 12, positive 12. Ooh, I like it already. So I'm down to a remainder of 0 right off the bat. Now, once again, so I know x equals negative 1 is good, which means this is really 1x squared plus 4x minus 12. And I can just factor this quickly here. You know, what multiplies to negative 12 and adds up to 4? 6 and 2 look good. If I make the 2 negative, I get my answers really fast. X plus 6 equals 0, x minus 2 equals 0. So x equals 2, x equals negative 6. There's my 3 answers. And just like that, I'm moving on to the next one. All right, so they can go pretty quick if you get good at this. All right, you try. This, I got number 6 on this. I might be off by 1. Find all rational roots of 2x to the third plus 5x squared minus 2x minus 5 equals 0. All right, so you can do that one and bring it to me in class. Have a great night, and I'll see you all soon. Bye. We'll close it out with some more music here. Find it. There it is.
To me tomorrow. Oh, what fun it all would be. Then what's to stop us, pretty baby? But what is and what should never be?